boys and girls, and welcome to the video on writing small numbers in scientific notation. Yesterday we learned about writing large numbers. Now we're going to do the opposite and write numbers, really small numbers in scientific notation. So at about this point you're probably wondering, where is Miss Fallstick? Well, I'm actually there, right down in the corner, but it's so small you can barely see me. If you put your head up close enough to the computer, you might be able to see me, but it's so small that you can barely see me. So I'm going to keep talking, even though I cannot be seen. All right, so what I did is I scanned a piece of my hair, a picture, into the computer and put it into this PowerPoint. And again, scientists and mathematicians use scientific notation to write very large numbers, as well as very small numbers. And we'll get more into detail in class about some other examples. But this is my hair, and what I did was measure the diameter, or the distance across the tip of a piece of hair. So if you're able to see your hair and it's long enough, what I want you to do is look at a piece of hair, and the distance or thickness of your hair is a very small number. 0.001 that should be of an inch to be exact. Let me change that real quick. So that's how small your hair is. We're 1/1000th of an inch. So 1,000th of an inch is how thick your hair is. And we can also use scientific notation to write those numbers as well. So here's an example. 0.00077. This could measure the thickness of a cell, which we'll kind of get to. This could measure the thickness of a piece of paper, maybe. Right? We also use very small numbers. Now, to write small numbers in scientific notation is very similar to writing large numbers. We want to get the decimal point after the first number, after all the zeros. So here's all the zeros. We get to our first digit, which is 7. And if we look at 7.7, that's a number between 1 and 10. So we're going to count the number of digits. 1, 2, 3, 4, 5. So to write this number in scientific notation, we're going to write 7.7 times 10 to the 5th power. But because it's a very small number, it's a number that's less than 0, we use -5. So you want to count the digits between the decimal point, 2, 3, 4, 5. So if we were to take 7.7 and slide it, and multiply it, by 10 to the -5th power, it would equal this number here. Let's look at another example. Welcome back to the Fallstick Flipped Classroom Freeze. As you can see on my clock, it is now 2:57 p.m. and I've been cooking chicken for about 8 minutes. At what time did I start cooking my chicken? If it was about 8 minutes ago. Put your answer at the bottom of the graphic organizer now for extra credit and so that I know you watched my video. Lincoln. Lincoln. Oh, is your toy hungry too? Thought so. Don't you love math? So here's another example of a very small number. What I'm going to do is place the decimal point after the first digits of 0. So 8.7. So 8.7. You can also box the number as well. Times 10. I'm going to count the number of spaces. 1, 2, 3 to the -3rd power. Here's our third example. I'm going to put my decimal point. I'm going to look at all the zeros. Here's my first number other than 0. I'm going to put my decimal point. You can also box this number. So 2.63 times 10 to the 1, 2, 3, negative 4th power. Okay? Now, what I want you to do is get out your graphic organizer, and we're going to fill out the section of writing small numbers in scientific notation. So you move the decimal point to the right and count the spaces. The exponent is negative. So my decimal point, I'm going to look at my first digit, is going to go here. 4.63 times 10 to the, ready, here we go. 1, 2, 3, 4, 5, 6, 7. Negative 7th power. Okay, this completes the, I almost said music video. Nope, not quite. The flipped classroom video on writing really, really small numbers in scientific notation. How many of you actually looked to see if I was in the corner of your screen? I'm really not. I promise. All right, have a good night.